Electromagnetic induction. Can a magnet produce electricity? Let's explore this. Michael Faraday, the English scientist, was the first person to prove that a magnet can create a current. To test this, he moved a magnet towards and away from the coil of wire connected to a galvanometer. He observed that there was a deflection in the galvanometer, indicating that a current is induced in it. The current obtained due to the relative motion between the coil and the magnet is called induced current. The phenomenon by which an EMF or current is induced in a conductor due to a change in the magnetic field near the conductor is known as electromagnetic induction. Let's now look into some of the experiments performed by Michael Faraday. Faraday arrived at a few conclusions by moving a bar magnet in and out of the coil of wire. Displayed here is a circular insulated wire with many turns connected to a galvanometer. Observe the deflection of the galvanometer needle when the magnet is moved in and out of the coil, different pole is introduced, and number of turns of the coil is changed. The deflection of the galvanometer needle indicates the presence of current in the coil. The direction of the deflection gives the direction of flow of current, and the speed of deflection gives the rate at which the current is induced. The deflection of the galvanometer needle indicates the presence of current in the coil. The direction of the deflection gives the direction of flow of current, and the speed of deflection gives the rate at which the current is induced. Deflection in the galvanometer indicates that the current is induced in the coil due to the relative motion between the magnet and the coil. The deflection in the galvanometer lasts as long as there is relative motion between the magnet and the coil. The deflection is more if the magnet is moved faster and less when the magnet is moved slowly. That is, the rate at which the current is induced is more when the magnet is moved faster. The deflection in the galvanometer is reversed when the same pole of the magnet is moved in the opposite direction or when the opposite pole is moved in the same direction. The direction of deflection indicates the direction of flow of current. The deflection in the galvanometer changes with the change in number of turns of the coil. More the number of turns in the coil, greater the deflection. The magnetic field goes around each loop of wire in the coil. So if we increase the number of coils, the change in magnetic field is more. A bicycle dynamo is the best example to observe electromagnetic induction. Bicycles have dynamos which rub against the tire of the rear wheel. As the bicycle moves, a wheel on the top of the dynamo turns a magnet inside a coil. This results in change in magnetic field, and as a result, an EMF or current is induced. This current is carried by wires to the front and rear lamps.